Let's go ahead and get started. Actually, did I hit the record button? I did. All right, this is it. This is the last lecture in steel design. So let's handle the business aspects now. So first off, I did not forget sign-in sheet.
The number one business aspect is you had mistake number 9.
Where? See, that's the thing, because it was right on my solution. I don't know. I must have fixed it beforehand. We'll call that 8.2. That's not a big mistake. Okay, all right. Okay. That's pretty good. Now, that's a good one. Okay, so the homework is due today. I need them here. So if you are just walking in, make sure you get your homework in. I am passing out the solution right now. Real quick on course eval, right before class, I had one student that hadn't done it yet, but there are 2 people who hadn't told me about it. If I get all of them, I'll give everybody an additional 5 points.
All right, I just turned mine in, so.
Y'all mess this up for us, we gonna find
So he just said, so by tonight at midnight, I'll give everybody in here an additional 5 points, but I got to have all of them. All I can see right now is how many have completed them. So. Oh. You're leaning towards this thing called a curve, and I've heard about curves before, but I don't really understand them. I know about curved balls, but
spirals that go in, circular.
that's a transportation thing.
How about just 1 point?
You can just kind of think of it as cambering the grade.
You want me to camber the grades? Camber. I gotta admit, that was pretty good. That was pretty good. Cambering the grades.
We'll all be dead.
My exams have never been that bad. They've never been that bad.
You can give us like a question on the exam for the conceptual. Like this is your free question.
If you think about it, I might have already done that. 2, 3, 4, 5. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 10. Yeah, I might have already done that, so. Man, that was good. I think that's enough. Okay. So, does everybody have a copy of the Homework 9 solution? If you have not turned it in yet, you need to do that now. I am going to go through the solution so that everybody's aware of what's up. All right, homework 9. What's that? Okay, so problem number 1, which is determine the strength of the following section. Now, you look up its LP and LR and find that LR is 12.3 feet and its unbraced length is 15 feet, so you're in zone 3. So you've got to go through and compute the FCR and look up all the properties accordingly. It's a pretty straightforward problem. I know that this is long, that this equation is long, so I mean it just takes a little bit of grunt work. The only thing I'll point out, LB is in inches here because it's inches over inches. So you can't have 15 divided by 1.51. It's got to be 180 so that your units cancel out. You should get 25.18 KSI. Make sure when you do your flexural capacity that you don't forget phi. Okay, you have to incorporate your phi value. Now it's the minimum of FCR, SX, and MP, but because CB is 1, you know that this one's going to govern. So your moment capacity, your nominal moment capacity is the 120.9, but adjusted by phi, your 0.9, that's where you get the 108.8. So your final answer on problem 9 should have been 108.8 foot kips. So that's problem 1. Problem 2, okay? So here's the deal on problem 2. Here you go. So you have a beam that is subjected to a distributed load and a point load. There was a mistake in regards to the loads being unfactored. If you went ahead and treated them as factored, no big deal. But one thing I am going to make sure of is that regardless of whether you use unfactored or factored loads, that wasn't the difficult part. The difficult part was making sure that you computed your C sub B appropriately. Now, if you use factored loads, you should have got a C sub B value of about 1.46. If you used unfactored loads, that might have changed a little bit, but shouldn't have changed drastically. Now, what I did for MA, MB, and MC is I used the equation. For M max, I just used WL squared over 8 and PL over 4. Bless you. If I had plugged in 20 foot here, it would have given me the same answer, so that's not really a big deal there. So you should have gotten 1.464. Now, your deflection limits will generate a minimum moment of inertia of 1489.7 inches to the fourth. So you go into your beam charts with MU over CB of 535.7 foot kips and an unbraced length of 20 feet. You're going to try a W27 by 84. You try that because you don't, I say it's a trial, because you have a C sub B that's not 1, you have to go back and check it, okay? So you go through, do your math, and you find that the section does indeed work, and also its moment of inertia is bigger than necessary, as well as its shear capacity, so there's your answer to number 2. Use a W27 by 84. Now, number 3. Number 3 is sort of a hip bone connected to the leg bone problem. You have a beam, but the beams are framing the girders. You're analyzing the girders. So here's what should be going on. So first thing I'm going to do is I'm actually going to analyze the beams. Now, the dead load incorporates the self-weight of the framing, so I don't need to account for that twice. So let's take some time with this. So first off, the factored load is 1.2 dead plus 1.6 live, comes out to be about 0.218 kips per square foot. Now, if I analyze B1 and just try and determine a support reaction, I get a support reaction of about 29 kips. So looking at girder 1, that model there at the bottom, that's actually the analysis model for girder 1. You have 3 point loads where those girders frame in, and it's 2 reactions. So you essentially have about 58 kips at each point, because if you look right here on this image, you have a beam framing in over here, a beam framing in over there. So you have 2 reactions, 2 reactions, 2 reactions. So you draw your moment diagram, that's what it looks like. The reason why I wanted you to go through and do all the CB stuff on this problem is your moment diagram is linear. So your MA, MB, and MC are really easy to find, because if you look at this segment, MB is the average of this and this, so it's that. MA is the average of this and this, so it's that. And MC is the average of that and that. So you can calculate those intermediate values quite easily. Okay? So your moment diagram should have been linear on 2 ends. What you'll find when you do your C sub B values is this. You have 4 segments on the beam, but the center segments are the same and the end segments are the same. Now, if you look at the center segments, here's what you're going to find. The center segment has a C sub B of 1.11. The end segments have a C sub B of 1.67. Now, so think about this. I want you to think about this in terms of a little bit of a common sense approach. This has, what's up? This has a lower moment, a lower maximum moment of 608, and it has a higher CB. This one has a higher moment, lower CB. So that center segment governs. You really don't even need to check the end segment because it's not going to govern. It's not the worst case scenario. So you can just ignore everything going on the end segment. For the center segment, you have a M max of 811, a CB of 1.11. So MU over CB is this, unbraced length of 7 feet. Try a W24 by 76. That's what you get out of the beam charts. Analyze it. You're going to find that it's not good, and here's why. Okay? Your actual maximum moment is 811. Okay? It's actually 811. Okay? Now, if you pick your first trial section as a W24 by 76, and all I have to do is look at this number and tell you it's not going to work, okay? Because I don't care what math you do, this beam is not going to have a capacity larger than 750, which is lower than our actual moment. So that section's no good. So the second section we end up going is the next one up, a 24 by 84. You analyze that one and you find you're good. So that's that. Any questions on that? What?
Yeah, we did the tributary area and we found a PSF load instead of the load.
Your moments actually probably won't be that far off. I mean,
I think it was like 840s or something.
they should be pretty close, but your moments are probably a little higher, right? So that's what it is. So, no, it's because your moment diagram, it's a little rounded as opposed, or parabolic as opposed to being just straight linear fits. So, yeah. Wrong is tough to determine on this problem because of the number of beams. Let me put it like this, okay? I'm going to be hit or miss. I'll be fine with what you did either way. Like if you wanted to use a distributed load, I'll be fine. But let me be clear on something, okay? The reason why I'm fine with you all using a distributed load is because you have 3 beams framing into this. What if you had 1 beam? That'd be a different story, okay? Now what if you had 6 beams framing into it? If you remember from when we discussed tributary area, I know we did it in concrete design, that the more beams that are framing in, the more accurate a distributed load approach works. So, and there's usually a trade-off, and it's usually right around 3 beams. So I'm fine with you all going with a distributed load. However, it would have been easier and probably a little more accurate on this to go with the point loads, but that's just me. So for this problem, I'm hit or miss. But if there were 2 beams framing in or 1 beam framing in, I'd say no, that's not correct. So.
Girder doesn't see the distributed load at the problem statement.
What's that?
Does the girder go with, like, help hold up the distributed load? The diagram, you only had the point loads for your actions.
Yes.
So would you also have need to put in the distributed load?
You're talking about the self-weight of the beam?
Yeah, like the two distributed loads.
I would say no, and here's why. Because the dead load that was on the system was, I don't remember the PSF, what was it? 75. And that 75, it says it includes the self-weight of the framing, right? So if you put self-weight on there, you're double counting. Do you see what I mean? Now, let me also say this. If you're trying to say, well, what about this little piece down here? You know, like, well, if I look at it from a tributary area approach, you know, that part goes there, that part goes there, but then there's that little bit down here. Well, that just goes right to the column and not to the beam anyway, so, or to the girder anyway, so it really wouldn't matter. Does that make sense? Yeah. Is everybody else okay with that?
So we're assuming those beams are on top of the girder?
No, that they're framing into them.
So the girder wouldn't see any of that distributed load on the girder itself?
It's not a matter of it not seeing it. It's that if you were to, what he's asking is that you would put distributed load and the point loads on there. And what I'm saying is you'd be double counting. Do you see what I mean? There's only, you know, there's only what is 38, 74 or 76, I did it right? 76 times 28. There's only 76 by 28 area of PSF on there. And my point is you just can't double count it. That's all I'm saying. Does that make sense? That's all I'm saying. Did you have a question? I would say, yeah, but going back to what I had said way back in the beginning of the semester, I would do that if you had, you know, 1 beam framing in, 2 beams framing in, maybe 3, and that's where I sort of get a little, you know, on either side. But if you had, you know, 1, 2, 3, 4, 5, 6, if you had like 7 different beams framing in, and you were to plot your moment diagram assuming point loads and your moment diagram assuming distributed loads right on top of one another, you really wouldn't be able to tell a difference. My point is that, you know, when you start to have an absurd number of beams, just treat it like you all did on your homework as a distributed load. But when you have a very few number of point loads, your accuracy changes quite a bit. That's what I'm saying. Does that make sense? Everybody okay with that? Any questions? All right, let's talk a little bit then about the exam, because that is the main reason why we are here. Okay. I'm not that mean.
Yeah, but I'm here.
Let's try it again. That is a retro shirt. Okay, so this is what is going to be on the exam, columns and beams. I would argue there's a fair amount of material on this exam. I've thought about, in future semesters, making exam 2 only worth 15% and making this one worth 25 because there's a lot on here. But I didn't, so. Okay. The exam, yep. That's concrete. So yes, there is development. What's that? I will test you on development link, just not on Friday. Okay, now hold on, let me see something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19. Well, I'll be. Everybody's here. So, I've been bringing this up for a number of days. I've said, if you all want to talk about moving the exam, I'm happy to have that discussion, but I won't have that discussion unless everybody's here. But everybody's here. So let's have this discussion right now. First off, you all know the format of the exam. There'll be 4 problems, 1 set of conceptual questions, and then 3 calculation-based problems. You can put whatever you want on your formula sheet except for worked out examples. I've got the exam starting at 8 a.m. on Friday, May the 5th, because that is our scheduled time slot. I have received requests or suggestions that we move the exam. Okay? I have been shy to do that because I'm not going to move the exam without everybody here. Everybody's here. So I will entertain a few minutes of discussion if you all are interested in moving the exam. What's that? No?
Oh, okay, okay.
What's this? Margaritas are calling, right? All right, how about this? How about this? How about Friday, May the 5th at 8 a.m.? Because
I'm cool at 9. I want some sleep, y'all. Yeah, can we take a vote to...
whoa, 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 whoa. I've seen a lot of head shaking and nodding on 9 o'clock. Does anybody have an exam at 10 o'clock or 10:15 on Friday? I need to know right now. Okay.
Y'all get, an hour. Let's go.
All right, this is what we're going to do.
Hey, what's the... Yeah. Can I bring a mark to class on Friday? I don't want a day drink. I want a morning drink.
Just remember leaving for Norfolk. Let's just... Yeah.
I want to say, if I chug it, you got extra. Do I get extra credit? I think it's sold off.
You're going to have 21 angry college students in here. That's all I'm saying. Okay, all right. Discussion's over on moving the exam. It looks like there's too many schedule conflicts and conflicting desires. We're going to stay at 8 o'clock, okay?
We also discussed maybe Tuesday, like a week from Tuesday, like May the like 9th.
Let's move on. Let's move on. So, real quick, scratch paper and staplers will be provided. Any necessary design aids, including the alignment charts for columns, you'll have that. So, let's talk about the material on the exam. Let's start off with columns. So, you need to understand the basics and the behavior of columns in general. You know, effective length factors, imperfections and residual stresses, what's local buckling, all that stuff, just the general concepts of columns. You need to be able to analyze columns using either the column curves, you know, what the equations that are in section E3. You need to be able to use table 4.1, and you need to be able to use table 4.22. You also need to be able to select or design economical shapes using table 4.1. Finally, you need to be able to use the alignment charts and Tau B if necessary. Remember, you don't use Tau B on your supports to compute K. So, in other words, using your alignment charts. So make sure that you're okay on that. Beams. Make sure that you understand basic beam bending and buckling. You know, make sure that you understand the what is the elastic neutral axis and the plastic neutral axis. What's the difference between the two? How do you compute ZX? How do you compute MP? What is lateral torsional buckling? You know, how does it work? What is moment gradient? What the heck does CB even do? Be able to analyze and design beams that are continuously braced and discretely braced. So continuously braced beams, you're going to use the ZX tables. Discretely braced beams, you're going to use the beam charts. Also, make sure you can do live load deflection. I would say shear, but there's really nothing to it. And shear is never a problem, so we really don't need to worry about it. Here's some stuff in the manual that might help. So number one, table B41A, your width to thickness ratios for compression elements and what have you. There's also your ones for columns and for beams, and they're right next to each other in the manual. I've even highlighted the cases that are important to us. Case 1 and 5 for columns, 10 and 15 for beams. Effective length factors. Make sure you know how to use the theoretical values. Use the recommended ones for design purposes. Make sure you understand your column curves. You know, that you understand the equations and how to compute FCB, how to compute FCR for inelastic buckling and elastic buckling, how you tell the difference. Make sure that you can understand how to use table 4.1, the column capacity table. Remember, bless you. Remember, you go into the chart with one of two things, either KL for the y-axis or an effective KL for the x-axis. And your RX over RY ratio is at the bottom of the table. Remember, we're looking up blue numbers, not green numbers. Bless you. Alignment charts. Remember, your G value is sum of I over L for over the columns, or the sum of IL for the columns divided by the sum of IL for the girders. G for a fixed support is 1, bless you, and for a pin support it's 10. Your tau value is computed as follows. Remember, you locate your G value on one side and your G value on another, strike a line, and that's your K value. Again, I don't care if the exact answer is 1.86 and you get 1.85 or 1.87. That's no big deal. You get 3.94, that's going to be a problem, okay? So, make sense? All right. Beam analysis aids, make sure that you understand how to use these. It would probably not be the worst idea in the world to at least put some stuff off this case on your formula sheet. I mean, I'm not saying you need to write every one, but this one, I mean, if you don't know WL squared over 8 by now, I mean, you should be pretty comfortable with that one. Make sure you understand your beam capacity curve. The idea is you have 3 zones, either full plastic moment capacity, a inelastic buckling region, or an elastic buckling region. If you have a continuously braced section and LB is 0, then your capacity is just MP. Remember, C sub B serves to increase your moment capacity, but I don't care what C sub B does, you're always cut off at your plastic moment at MP. Make sure you understand that. Your equations, zone 1, phi Fy ZX, zone 2, that linear fit, again, the minimum of that in phi MP, or zone 3, phi F critical SX, or phi MP, whichever is smaller. C sub B is calculated as follows. You can also find that in table 3.1, and FCR is computed using that equation. The rest of the factors you can find in table 3.2. So you should be good to go. And that is exam 3. So with that, I am going to shut up and let you ask whatever you want. You mean making you do structural analysis?
We done passed.
So there's not gonna be any class tomorrow, but that was this class, right?
That was this class. Hence why it's a good idea to have the concrete exam on Monday and this exam on Friday. All right. Now, as for this structural analysis, if you go to page 1 of the syllabus, and it lists the prerequisites for this course, one of the prerequisites is structural analysis. Yes. Yeah. Very possible.
But it's not on here.
Yes, it is.
Where?
Hold on. Wait.
Oh, I see DNA, never mind. I'm here in body, not spirit. I left my spirit on that.
You astrally projected back to your apartment. Anything else?
No development week.
Not on Friday, but on Monday. What's that? No, concrete, he's going to say, so do we have to worry about CISA B in here? It's like, well, you do for development lake because there's a CISA B in there too. Yes, sir. That's, again, a concrete one. It's a concrete one.
Does concrete behave well in tension?
Oh, I can't wait for concrete design. This is just like any other normal exam. The topics themselves are a tad longer, so there's nothing really I can do to make a column problem or a beam problem shorter. But again, you will have one set of conceptual questions, 3 calculation-based problems, just like before.
So I was a little, I guess, hesitant to put full design problems on the exams. Will that change?
That's a fair question. What I'll say is this. I've been hesitant to put open-ended design problems on exams. The design problems that I've put on the exam so far are ones that are fairly closed in their solution. In other words, everybody should arrive at the same answer. What I will say is, if there are any design problems on this exam, the same thing will happen. In other words, I want everybody to arrive at the same answer. And that's just for your sake and for mine. If everybody should arrive at the same answer, then there really should only be one path towards the correct answer. Plus, I don't want to grade an exam where there's 22 responses and they're all right, because that means I have to go through every single person's individual design. So I'm not a fan of open-ended design problems on exams. That I won't do. That I don't know who was first. You go ahead. I do not expect anybody to be going down to the wire. I don't expect anybody to be going down to the wire. No. Right now, this is what I was saying to her earlier. By their very nature, column problems and beam problems may be a little longer, but I do not. It is not my goal to take the exam and make it longer because I've got more time. I'm not doing that to you all. I don't expect anybody to be, having to call the clock on them. And if I do call the clock on some people, maybe a couple of you, not everybody. So that's my prediction. And I've given similar exams to this before. I'm not a time cruncher guy. That's not the type of exam I like to give. Because My thought is I would rather give you all an exam that where time isn't an issue, because I just want to see whether or not you can do the math or not. And my what's that? Algebra. That's a calculation error. I mean, look, I'm an equitable guy. My opinion is, however vital that calculation is to the problem is how much it's worth. But I'm not of the opinion that even if it's the only part of the problem, I mean, if you have all the right input and it's just a plus where a minus should have gone, I don't think that is worthy of, 10 points off, So don't worry about that. I mean, I'll treat calculation errors like I always do. Yes. I'm not into giving that kind of information.
Also, so I mean, the conceptual set within one column and then two beam columns.
Wait.
We have three workout problems, calculation problems. We have two top beams and columns. So I was thinking probably one column and two beams.
Could be 2 columns, 1 beam. It could just be 3 beams. I could just, say, oh, the hell.
Not into that kind of stuff. I like the way you worded things.
I'm a little worried. What do you mean? I don't.
I'll just try to tell it good.
Oh.
I said you're not into that kind of giving us a lot of information.
I
Listed the words.
I can guarantee you at least one of your workout problems will be a column problem. At least one of them will be a beam problem. One or the other. Well, that's a beam problem. We got plenty of time, so especially for those of you who are going to be here for another hour after this. Broad.
I'm with you.
Oh.
I want to know. What will that be?
Oh God. No, it won't be on the.
I wrote, after taking this course, I now have a better understanding of why Bush did not.
God. Well, my time at Marshall here has been fun. Now, what you gotta check for is when you're on the phone and you just hear this click. That's the wiretap catching. That's when the wiretap being turned on.
We're gonna be out for a run, and Will's just never gonna come back.
SUV. Thumbs up. These people with headsets, and then where's Will? He hadn't been to class in a while. I'm staying out of it. I'm staying out of it. Let's talk about columns. Let's talk about beams. I know with some of you all who are dressed up and getting ready for something that's going on this afternoon. It's like these senior design presentations. They're no big deal, right? Minor stuff. Now, I've got all these geotech folks in here too.
Yeah, I don't know that.
I thought it was like 1203 and 1205, like with the wall taken out.
How would you?
One, right?
Will there be people sitting at both sides of the room?
What's that?
Will there be people sitting at both sides of the room?
I have no idea.
There's gonna be so many people. They're gonna have to be outside looking through the window.
They're going to have to be on the lawn in front of the science building. Yeah.
Are we gonna upload it to YouTube?
All right, we got plenty of time, so I really want to exhaust any potential questions you have on the exam. I really want to dig for all of these questions now because I know this exam is next Friday, but the concrete exam's on Monday. So I'm sure that right now your initial worry is, well, we got the concrete exam on Monday, but this is your chance to ask steel questions, so I really want to make sure that we're exhausting any of those.
Will you be around next week?
I'll be around.
I think he's contractually obligated to be around. Is it homework 6, 7, 8, 9?
Yes, 6 was the first column homework, right?
It's not. That's what I was thinking. I was like,
What? No, but if you look on the title of the homework, I put homework assignment 6, and then.
So much extra better than this.
You mean studying?
Yes.
Homework 6 to
9.
Of course
Look, whenever I get these graded, I will put them in the box.
I have a concrete for Monday.
That is a crapshoot. I don't know. I really just don't know.
give you $1. You get a crap.
I won't, but
All
look at it this way. If it's not graded by Monday,
Have you met, dude, have you met Dr. Wade? We have homework due on the day of the exam, and those problems are on the exam. So we know how site works.
No love for it. It's just
watch. We have homework due Tuesday and Thursday.
You're getting the solution in 20 minutes, so. Anything at all, please, anything.
What's the little C again?
The little c, oh, it's an adjustment factor for channels, but for us it's 1.
Okay.
The question was about that, the little c.
Do we need to know the different equations behind being buckled?
No, but it would be nice for you to understand the concept. That's about it. But that's for the exam after this one, right? Or no, the one after concrete, right? Isn't that when the Q exam is?
No, it's wait. It's Monday. I don't remember.
How do you think you will Laplace on that exam? What was that? I know. I know it's.
I don't know what's correct.
I know it's the Laplace transform. Have you all done Laplace transforms in there?
We just did. Yeah, we did it last week. Let's talk about the actual
No. Well, we started them last week. We kind of just finished them. We got a table and all the
That's all we did.
F of t and big F of s and all that.
She talks straight BS about the engineering department. Like people across the street think it's okay to just plug numbers in equations.
We get a softball every time.
Who's your professor?
Lawrence.
You're right. That's all we do in this class, right? We just plug in the numbers. Like we don't have to make any decisions about anything, right?
We look at the Bible as well.
Yeah, she's like,
The Steel Bible.
We pray.
What? Wasn't that like everyone in the class though? Don't hold back, Mr. Crookshanks. I mean,
You said plumbing.
The thing is, she doesn't have the sense of humor to like get it. She's just like, why would you be in here?
all right. Let's settle down and get back to columns and beams.
How many points would we get if we made a mistake on that?
What? What?
If you, hypothetically, if you were to make a mistake on the exam, like
Depends on the mistake.
2 number 2s on there or something.
two number twos on the problem or two number two bars? Because that's concrete design. Actually, it begins at number 3. It depends on the mistake. Goodness.
Yeah.
What? I can't. What? I'm not. It's fine. I promise. It's a good question. Do you have to do live load reduction? The answer is no. We actually didn't cover that in here this semester. We covered that in concrete. It would be applicable in here, though. I mean, it's still beams with live loads on them, but no. Are you all worried about the exam, or are you feeling better about the exam?
Not really decided yet. That's gonna be a Thursday night.
Well, what about the Sunday night thing?
Well, that's concrete.
I know. Well, I've had a lot of concrete questions in here, so.
Not that one either. That'll be a Sunday night thing.
I really do think that if you have a sombrero each year to the exam,
A sombrero.
it is secret, like it's secret life.
Oh, I did have on my computations exam, the computations exam is that Thursday, so I had a little image on my review slide that said, "May the 4th be with you."
So we have cake for your first date. Are we gonna have cake for mine? Because that's also the final day.
Mine is right under the final.
Mine's
Can
an
we have cake on both your phones? I know, I get all the food that I approve.
Can we just have a keg instead of cake?
Oh my goodness.
I want a blender. I want tequila and margarine.
I mean, don't even, be subtle about it. Just say, I want a bottle of Jose and I want margarita mix.
Alright, anybody who wants to give me $4 to buy sombreros.
Ooh, they're embroidered.
What's the other thing?
Did you say, what's the point of an unembroidered sombrero? All right. Settle down. See, it's that semesteritis kicking in. Is that what it is? That actually kicked in right around February, so. That's why I call it semesteritis.
Out of 5?
All right. Back to steel design. Columns, beams.
So how do we use the width thickness ratios?
What's that?
How do we use the width thickness
You basically just compute your lambdas out of the tables and compare those to the BF over 2TF and the H over TWs. What you should get is that the BF over 2TF and the H over TWs in the manual for a shape, like for a W10 by 49, that those slenderness values are less than the limit. If they are larger, that would mean you use a different set of the spec. I'm not going to make you all use that different set of the spec. I'm more interested in you all understanding what that phenomenon means. Again, if you put a feather on the beam, it does not mean it explodes. It just means that the flange or the web buckles before the whole thing does. It's just a different set of equations. I didn't say you didn't have to check it. I just said you aren't going to have to evaluate it if it fails. That's what I said.
Do you have to check it and it doesn't pass? You just use a different shape instead of using a different one of manual?
For the purposes of what we're talking about, yes.
Can I see your manual so I can make sure my tabs?
You could go through the slides and find everywhere there's a star.
I'm too busy paying attention,
Sorry. That was mean. See, but it's so big you can't have the quick, takeaway. That doesn't really work out. Well, we got 5 minutes. So I really want to exhaust, again, any potential questions. We're not going to begin that.
That's blue, right?
That's
That's a concrete
It's
question.
relative.
It's real.
Come on, you don't have to
What's
Like
your
I said
favorite
before,
method?
what if we all
my
had
favorite
the
what?
same exact favorite color that we just
We'll take a wild guess on that one. Aluminum. Yes.
I got a question.
We know you so well.
What element would you add to steel to make it stainless steel?
What?
That's a Jeff Buckner question.
I don't care about stainless steel.
It's still a steel.
Stains or not, it's still.
I know what element you add for weathering steel.
Time to go. Time to go. And you put them right in. They call it paint.
All right, would you rather have your local would you rather have your local WNBA team win a national championship or have $5?
You've told me that one before.
The poll was overwhelming.
That was pretty sick.
That, come on. That has nothing to do with columns and names.
I don't know. You're right, it doesn't. But
Is it $5?
it's always $5.
Okay.
$5 every day of the week.
The poll was like 75%.
I'm going to be honest, though, if anybody said anything for any sports team, like, would you want this team to go to the Super Bowl or have $5? I'd probably just want the $5.
What about Marshall? You know, you have some Marshall comfort out.
Marshall got rid of the Super Bowl. Don't even answer that one. I don't want to know.
$5 will get me lunch.
Team, you wouldn't want them going to nationals for $5?
No, that's different. I'm involved in that. I'm not involved in the, the. That's a different question, though. No, the question was if any team would go to, not if I had tickets. That's a different question.
Well,
If I had tickets, like you said, I could just sell them.
well, no, if they go, you automatically get tickets.
That's, and I agree with you. I agree with you on that. It's a financial incentive. All right. We're getting way off topic, which is starting to make me think that we are exhausting our questions. So I'm gonna do what I always do. You good?
I guess.
Got anything else?
Yeah, he's
Good.
Yeah.
You two good? You good? You good? You good? Mr. Atkins? You two good? You geotech folks good? You two good? You two good? You good? You good? Mr. Lewis, you good? All right, real quick. For those of you that are not in concrete design, this is likely the last time I will ever have you in class. So I will say this. It's been an absolute blast and an honor to have you all in class this semester. Steel design is a fun topic for me to teach, and I think you all have had some fun learning it. At least, that's the vibe I've gotten. I hope you've had fun. I hope you've learned something. I think you will find that this knowledge is incredibly useful when you get out of here. This is not IJK. This is real world stuff in here, using real specifications to select real elements and whatnot. So with that, I'm going to shut up. I'm going to leave you all to it. If you all ever need anything in the future, don't hesitate to contact me. And with that, we will see you next Friday at 8 a.m. Oh, stop with that. Stop with that.